All right, so here we go. Let's just practice all kinds of different types of factoring. So the first one says 2x cubed minus 5x squared equals 3x. What is the very first thing you need to do every time before you do any factoring? Set it to 0. So I'm going to subtract the 3x from both sides and go 2x cubed minus 5x squared minus 3x equals 0. Okay? Callista. Oh, no, not necessarily. You can if you want. I just gave that to you for you to keep so you could see the different methods that we've learned. So if you're stuck, you can kind of go through that and try and figure out which one matches which, okay? All right, so now what? Right, so this would be an example when you look at the notes that I gave you of the very first one, factoring out the GCF, factoring out the greatest common factor. In this case, there is no number that goes into 2, 5, and 3 all evenly, but since all three terms do have at least an x, we can factor an x out of each one of those, which means, bless you, each one of the other ones gets knocked down by 1 power, so x cubed becomes x squared becomes regular x, and the last x disappears. Emma? Oh, I thought you just raised your hand. Okay, then when we have it down into the trinomial like this, that is an example of the second case right here, where we're going to try to factor that by putting it in 2 parentheses, okay? So the x stays out front, and then I'm going to put some double parentheses right there. This is a little bit different than some of the ones we've done because instead of starting with an x squared, it starts with a 2x squared. What are the numbers that have to go in front of each parenthesis so that when they multiply together, we'll get 2x squared? X and x, in other words, does not work because x times x is only x squared. We want a 2x squared. 2x and 1x, yeah. So this is going to be 2x and x, okay? From there, we're just going to do a guess and check, okay? We know the last two numbers have to multiply together to be 3, right? And there's only two numbers that multiply together to be 3. What are they? Right, 1 and 3. So I'm either going to go a 1 here and a 3 there, or I might end up having to switch those around. The way that I'm going to check is if I were to FOIL these out, what is 1 times x? So this inside would give me just a plain old x. What would this one give me? 6x. Is there a way that I can combine the 6x and the x to get a negative 5x? Yes. If this is, yeah, good. If this is a negative 3, then this will give me a negative 6x. And if this is a positive 1, then that will give me a positive x, and together those will combine to be negative 5x, okay? So we could have factored this by doing that this number times this number thing, and then breaking it down from there and doing that whole factor situation. But sometimes it's easier to just guess and check, okay? All right, so we have the original polynomial now completely factored into x times 2x plus 1 times x minus 3 equals 0. There are 3 pieces, which means that we have 3 answers. What is one of them? 0, good. For this to equal 0, x has to equal 0. Close but not quite, because this 2 is there. If I plug a negative 1 into here, 2 times negative 1 is negative 2, plus 1 is negative 1, not 0. Chris? Negative 1/2, yeah. Because if I write this out, 2x plus 1 equals 0, how would you solve that for x? You would subtract 1 from both sides, and then, okay, and then divide by 2, so you would get x equals negative 1/2, okay? Okay, and then what does this equal? 3. All right, so that is what? Still stuck on the one? But I think you do. You just are overthinking it. If you had walked into this class like a month ago and I said, hey, Callista, 2x plus 1 equals 0, can you solve that for x? You'd be like, right, exactly. Okay, so these are my three equations, okay? Okay, will you now get out the piece of paper that you're going to do the assignment on? We're not done because we have other factoring things to practice, but I'm going to give you a handful of just these to do. I'm going to give you about 10 minutes to work on them, and then we're going to come back together and we're going to practice the next type of factoring, okay? So for the next 10 minutes, on a piece of paper that you will turn into me as your homework, will you do these problems? Okay, yeah, give me just a quick second here. Yeah, I haven't given a page yet. All right, will you guys do those three problems real quick on your own, on your homework page? Yeah, this goes on the piece of paper that you're going to turn in as your homework. I can't reach either. Maybe Zoe will hook you up. What? There's no what? Hold on just a second. Nice call, Emma. Way to save the day. Yes. Don't ever say that about me. I care very much. I'm trying to, just give me a second. All right, so there is another trick that we have not used yet that sometimes is exciting, and that is if you have something like this. So let's say you start with x to the fourth minus 3x squared equals 4. Again, the same first step as always is to do what? Set it equal to 0. So I'm going to start by subtracting 4 from both sides to get that set equal to 0. Okay? Now, Callista and Brennan, since I have a trinomial, that's sort of a clue that I'm going to put this into double parentheses like that. Okay? But this time, instead of an x and an x going in front, because those would multiply to give me an x squared, what needs to go in front to... Good. This would be an x squared, and this would also be an x squared, because x squared times x squared is x to the fourth. Okay? And then we do the same thing that we do with the other ones. What two numbers multiply together to be negative 4 and add to be negative 3? 4 and... Negative 4 and positive 1. Yeah. Okay? Negative 4 times 1 is negative 4. Negative 4 plus 1 is negative 3. Okay? Now we can break this down a little bit further. What does x squared minus 4 factor into? What two numbers multiply together to be negative 4 and add to be 0, Callista? This is just an example from the notes. Okay? What two numbers multiply together to be negative 4 and add to be 0? Yeah. Good. Positive 2 and negative 2. And since those are the same numbers but opposite, this is an example of a factor pattern that you guys should recognize pretty quickly, called the difference of two squares. A squared minus b squared factors into a plus b times a minus b. So it's the same thing as this. Okay? And then x squared plus 1, sadly, cannot factor, because there's no two numbers that multiply together to be positive 1 and add together to be 0. Okay? So now the fun begins. What does x equal right here? Negative 2. What does x equal right here? 2. All right. If I take x squared plus 1 and set it equal to 0 and solve for x, what's my first step? Subtract the 1, so then I have x squared equals negative 1. Then what? Good, square root. What is the square root of negative 1? Nice. Plus or minus I. Okay? And the only reason why we are including those two answers is because it specifically says what are the real or imaginary solutions of each polynomial equation. It's bad enough that you told me that I don't care. Don't start making fun of my speech impediment. Specifically, simiminin. Specifically. Okay? All right, so let me give you guys a couple of those to try on your own. I will try to pick the right ones this time. I'm going to say number 20, 21 on the previous page, and 22. Let's do those. Yep, so now will you add on from the previous page, page 301, numbers 20 through 22. Okay? So those are all x to the fourth ones. See what you can get out of that. If I can just tear you away briefly from your really hard work, Peyton is noticing that the first problem is really similar to this one, except that it factors into x plus 3, x minus 3, right? And then you're left with x squared minus 1. So what I've been telling Peyton and Abby is that that factors into x plus 1, x minus 1, right? Peyton asks a very good question. Why didn't we factor x squared plus 1 into x plus 1 times x minus 1? And what is the answer? Because it would not equal positive 1, right? So this has to be a subtraction sign for that to work. Since it was a plus sign, it's not going to work out, okay? Great question, though. Thanks.